Dear students, welcome to Nivi's Patashala. In this video, we will be studying about non-deterministic finite automata. So in non-deterministic finite automata, the machine can read more than one input symbols at a time, and it can also move to more than one state. In deterministic finite automata, the machine reads only one input symbol at a time and it moves to only one state. But in non-deterministic finite automata, it can read more than one input symbols at a time and move to more than one states. So here we cannot predict or determine to which state the machine will move next. So therefore we call this to be the non-deterministic finite automata. The mathematical representation is given in a 5-tuple format. We have Q, sigma, delta, Q naught and F. Q is all the states we have in the NFA. This is the alphabet which represents the input symbol. This represents the transitions. Q naught represents the start state and F can represent the final state or n number of states. Here also we will be having only one start state. We can have one or more than one final states. So here we have an example to understand NFA. We have Q naught, Q1 and Q2, where Q naught is the start state and Q2 is the final state. We can see that Q naught on input A can either loop it to itself or give it to Q1. So Q naught on input A, here it is looping to itself, or it can also give it to Q1. Q1 on input B can loop B's to itself, or it can give B to Q2. And Q naught on B is giving it to Q2. This is the mathematical representation. We have Q showing all the states, that is Q naught, Q1 and Q2. The input alphabets or the symbols are A, B, and Q naught is the start state and Q2 is the final state. Here we have the transition table for the diagram, where in the first column I have all the states, that is Q naught, Q1 and Q2. Q naught is the start state and Q2 is the final state. In the first row I have the input symbols A and B. Now we can see that Q naught on input A, that is Q naught on input A, can either loop it to itself. So here we have written Q naught, or it can give that A to Q1. So here we have also written Q1. So Q naught on input A can either go to Q naught or Q1. And Q naught on input B, it is going to Q2. So Q naught on input B is going to Q2. And Q1 on input A has no transitions, and Q1 on input B can either be in Q1 itself or it can go to Q2. So Q1 on input B can be in Q1 or it can go to Q2. And Q2 on input A and B has no transitions. So this is the transition table for the NFA diagram. So here we have the NFA and we also have the transition table. So now let us check if the string AABB is accepted or rejected by the NFA. So the start state is Q naught and we have the first input cell having A. So Q naught on A can either loop it to itself or it can give to Q1. So that is what we have written here. Q naught on A can be in Q naught itself, or Q naught on A can go to Q1. So this is for the first input cell A. So now for the second input cell we have another A. We have to give this A to Q naught and Q1. So when I give that A to Q naught, it can either go to Q naught itself. So Q naught can loop that A to Q naught itself, or Q naught can give that A to Q1. Again from Q1 there is no transitions for input A. So there is no transitions here. So Q1 has no move. So this will end right here. So we have finished both the input cells. Now the third input cell is having B. So I have to give B to Q naught and to Q1. So when I give B to Q naught, it is going to Q2. So B on Q naught is going to Q2, and when I'm in Q1, if I have B, I can loop it to Q1 itself, or it can go to Q2. So here I have Q1, and then here I have Q2. Now the fourth input cell, the last input cell, is also having another B. I have to give that B to Q2, Q1 and Q2. So when I give B to Q2, there is no transitions for B from Q2. That is, Q2 is receiving B's from Q0 and Q1. It is not having any movements for A or B. So this also ends here. So from Q1, B can get looped in Q1, or that B can go to Q2. That is, from Q1, B can get looped in Q1, or that B can go to Q2. And again from Q2, here also I have no transitions for either A or B. So this also ends right here. So we have finished AA, BB. Now the last two states are Q1 and Q2. Q1 is a non-final state. Q2 is a final state. So we can tell that with respect to state Q2, the string is getting accepted. So AA, BB is getting accepted. Q0 on A is again getting looped in Q0. On the second input A, it is going to Q1. On the third input cell B, it is going to Q1. And on the fourth input cell, that is the last cell having B, is going to Q2, where Q2 is the final state. All the other states have no other moves. So it is left idle, where Q2 is the final state. Therefore, the string has been accepted. So let us take another example. Here we have to construct an NFA to accept A's and B's ending with A, B. So the first step is to identify the minimum string, that is AB. The string is ending with A, B, and the input symbols are A, B. The alphabets are A, B. Now let us construct the NFA. Here we have a DFA to show the DFA ending with AB. So when I have a DFA ending with AB, this is the diagram. We have a DFA ending with AB. Now when I have to construct an NFA ending with AB, we can see here I have Q0, Q1, Q2. Q0 is the start state, where A is going to Q1 and B is going to Q2. So I have A, B, which is the minimum string, and I have looped n number of A's and B's in Q0 itself. That's all is the construction for the NFA. So what happens, n number of A's and B's, I am looping it to Q0, and AB ending with AB goes to Q2. We should not worry about what happens if my string is ending with only A or ending with only B. Here we are constructing only based on the question where they have asked the strings accepting ending with A, B. So AB is accepted. So my string can start with n number of A's and B's, where A, B is accepted. That's all is the construction for NFA. So let us see the transition table and the mathematical representation. So here we have the transition table, where Q0 on input A can loop it to itself or give it to Q1. That is, Q0 on input A can loop it to itself or give it to Q1. Q0 on input B is looping to itself, that is Q0. And then Q1 on input A has no transitions, and Q1 on input B is going to Q2. Q2 on input A and B has no transitions. The mathematical representation, we have all the states for Q, that is Q0, Q1 and Q2. The input symbols are A, B. Q0 is the start state, and Q2, that is F, is the final state. Thank you for watching. Don't forget to like, share and subscribe.